We are converting the chapter pressure into the form of question answer, and this is part 2. Let's start. So we are starting with question number 5 because till 4 done in previous class. Okay, state Pascal's law. What is it? Exactly what is Pascal's law? According to Pascal's law, pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the directions. And I'm not going to explain about this law because next question is related with this and we'll get a little meaningful idea about the Pascal's law in next question. Verify Pascal's law experimentally. We can verify Pascal's law experimentally with the help of this device, and we have to draw this diagram in examination also. Now, as shown in the diagram, a spherical vessel is completely filled with water and is fitted with 4 pistons M, N, O and P. The name of the piston is given M, N, O and P of equal diameter. All of them have same diameter. If a force is applied on one of the pistons, say it is M, all other piston is found to be moved away by the same distance. What it means? If we apply force on piston M, then the same pressure transmit to N, O and P also, and they are pushed away from their original position, and what is found, all of them are pushed by the same distance. If N moved to 1 centimeter distance, then O also moves to 1 centimeter and P also moves to 1 centimeter. It proves Pascal's law, which states that pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the direction. The reason is very simple. All of them are receiving the same pressure. That's why they are moved to same distance. This way we can verify Pascal's law experimentally. Okay, let's go to question number 7. With the help of the given diagram, answer the following question. This is the diagram, and in the diagram a polythene bag is shown and it is being squeezed and water is coming out through different pores. Now, which principle is proved by the given diagram? Certainly it is Pascal's law, because pressure exerted at a point transmit to other point. Okay, now next, state the principle. Answer is Pascal's law, and state the principle means we have to write Pascal's law. The same law we are writing, pressure exerted at any point in a confined liquid transmits equally and perpendicular to all the directions. Okay, now let's go to another question. Number 8, name the devices based on Pascal's law. There are 3 major devices. 1, hydraulic press, another hydraulic brake, third, hydraulic lift, which is also called hydraulic garage lift because it is used in garages, and these are the devices which are based on Pascal's law. Okay, now let's go to another question. It is related with this diagram, and the question is, if the area of the piston M is 0.05 meter square and that of P is 0.15 meter square, what force produces in N when 40 Newton force is applied in piston M? This is the question. This is numerical problem. And now we have to write first the given area of the piston M. That can be taken as A1 is 0.05 meter square. It is in question. Area of piston N is denoted by A2 and it is 0.15 meter square. Force on M is F1. This is equal to 40 Newton, and force on N is F2. This is the question. Look at this. According to Pascal's law, pressure on M is equal to pressure on N, because the pressure exerted at this point is transmitted to this point. I mean to say, pressure from M is transmitted to N. Pressure is same in both the pistons. That's why what can we say? F1 by A1, that is related to M, is equal to F2 by A2, which is concerned with N. And taking the value in place of F1 40 Newton, in place of A1 0.05 meter square, F2 remains same because we are going to calculate it, and A2 is 0.15 meter square. While taking all this value, we will get the answer 120 Newton. It means the force which appears in piston N is 120 Newton. Okay, we have to write one sentence for our answer also. Therefore, force on N is 120 Newton. Let's go to another question. This question is also related to a diagram. This is the diagram given, and the question is the value of force and area of the piston is shown in the given diagram. According to the given information, calculate area of piston Y and force on the piston Z. There are two questions. Okay, we have to write first the given force on piston X, which can be represented by Fx equal to 225 Newton. It is given area of piston X, that can be represented by Ax, is 30 centimeter square. Force on piston Y, Fy equal to 200 Newton. Area of piston Z, Az equal to 5 centimeter square. Area of piston Y, Ay equal to question mark, and force on piston Z, Fz equal to question mark. Now, how can we get the answer? It's very simple. What can we say? We have Fx by Ax equal to Fy by Ay, and this is equal to Fz by Az. Why we are writing so? Because pressure on X is equal to pressure on Y and pressure on Z according to Pascal's law. Because when we apply certain force at this point, then the pressure exerted at this piston transmit to Y also and Z also. That's why pressure on this X is equal to pressure on Y, and pressure on Y is equal to pressure on Z. Okay, now we can write the value. Fx is 225 and Ax is 30 and Fy is 200. Ay remains same because we have to find Ay. This is equal to Fz upon Az is 5. Now, from the relation of first and second means X and Y, 225 upon 30 is equal to 200 divided by Ay, and we can calculate Ay, and it is 26.67 centimeters square approximately. Okay, in the same way, now we have to find the another value also, Fz. We can take the relation between first and third, because in first case we have both the information, in third case we have only one information, that's why fourth can be calculated. So 225 divided by 30 equal to Fz by 5. Fz can be calculated. Its value is 37.5 Newton. This way we can solve the numerical problem. Now one sentence for our answer. So the area of piston Y is approximately 26.67 centimeters square, but the force on the piston Z is 37.5 Newton. Okay, let's go to another question. What is hydraulic press? Now answer is hydraulic press is a device based on Pascal's law which is used to magnify the force. We have to remember 2 points. It is based on Pascal's law and it magnifies the force. Now, why liquid is used in hydraulic press? The reason are a liquid is used in hydraulic press because there are two major reasons. Number one, a confined liquid transmits pressure equally in all the direction perpendicular to the surface, and number two, liquid cannot be compressed. These two are the reason why we use liquid in hydraulic press. Now next question, why a hydraulic press magnifies force? Write down with the help of diagram. This is the diagram. Now in this diagram, a small vessel and a big vessel is connected to each other by means of a narrow tube, and small piston is taken on the small vessel and big piston is taken at the mouth of big vessel. Now with the help of this diagram we can explain like this. When a small force is applied on the small piston, this piston, then it exerts pressure on the liquid, and according to Pascal's law, the same pressure transmits to the big piston. From small piston to big piston, same pressure transmits. Pressure exerts a huge amount of force on the big piston because the area of this big piston is very huge in comparison to the small piston. So, a heavy load placed on the big piston can be lifted with the help of a small effort. Thus a hydraulic press magnifies the force. The major reason is the same pressure transmits to big piston, but area of big piston is very huge, so the force magnifies. Okay, write down equation to solve numerical problem related to hydraulic press with the meaning of symbols used in the equation. Actually, we have already used this equation F1 by A1 equal to F2 by A2. It will be better to have clear idea about this. That can be understood very easily with the help of this diagram. Two vessels, small vessel and big vessel are connected, and there is small piston on a small vessel and big piston on the big vessel, and force is applied generally on the small piston to raise a heavy load placed on the big piston. Okay, this is our equation. Here we have only symbol, and we have to understand the meaning of the symbol also. That's why we have to write this also. F1 is force acting on a small piston, but A1 is the area of the small piston. F2 is force acting on big piston, and A2 is area of the big piston. Instead of writing symbol, we can write directly like this also. Force acting on the small piston upon area of the small piston is equal to force acting on the big piston upon area of the big piston. But instead of writing so many words in the equation, it would be better to have F1 by A1 equal to F2 by A2, and we can understand this very clearly with the help of this diagram. Okay. Next question. How can we prove that hydraulic press is an effort multiplier? With the help of the previous diagram of question number 14, let the area of a small piston A1 equal to 1 meter square, area of big piston A2 equal to 25 meters square. This is just the assumption, but may not be 25, maybe 20 or maybe 50. If an effort of 100 Newton is applied on the small piston, then according to Pascal's law, same pressure transmits to the big piston. Now, the force exerted by the same pressure can be calculated by the following equation. F1 by A1 equal to F2 by A2. Now force is 100 Newton, area is 1 meter square, and F2 we are going to calculate, and area of the big piston is taken as 25 meters square. If we calculate, then what we will get? F2 equal to 2500 Newton. Thus 100 Newton effort magnified to 2500 Newton. It proves that hydraulic press is an effort multiplier. Let's go to another question. Write down any two practical use of hydraulic press. Hydraulic press magnifies the force, so it is used for the following purpose. Number 1, in making cotton bundle. Number 2, to raise heavy loads. Now next question. This question is related to a diagram. That's why I am showing diagram. Now question is, if the cross section area of piston X is 60 centimeters square, piston Y is 180 centimeters square, and effort of 40 Newton is applied on X, then how much load is needed on piston Y to balance it? Now this is the question. This is numerical problem. Now how can we solve? Area of piston X, that can be represented as A1 equal to 60 centimeters square. Area of piston Y, that can be represented as A2 equal to 180 centimeters square. Force on piston X, F1 equal to 40 Newton, and force on piston Y, F2 equal to question mark. This is our question. Now we have F1 by A1 equal to F2 by A2, or we can write the value 40 Newton divided by 60 centimeters square equal to F2 by 180 centimeters square. Now F2 can be calculated easily. It is 120 Newton. This way we can solve this numerical problem. Therefore, one sentence for the answer: 120 Newton load is needed on piston Y to balance the load. Okay, today we were focused on Pascal's law and numerical problem related to the Pascal's law and especially hydraulic press. Okay, next class we'll meet with the same chapter, pressure, in part 3. This much for today.